So in lesson 5, you learned a little bit about functions, being able to define your own sets of commands that once we have them defined once, you can repeatedly use. And we can, instead of having to repeat a set of directions, a large set of directions or a small set of directions over and over and over, we can basically define it once, give it a name, and then every time you want to run that small or lengthy set of directions, all you would have to do is call that function, and the computer now knows what you mean by that name. Right? So why bother doing this? Couldn't we skip all of this nonsense and just be able to write out our directions and have a, so what? It's a big long set of directions. Why does it matter? First, functions allow us to define your own commands. We saw in lesson 4 that many of you were frustrated that I couldn't turn right, or that I couldn't do something. I had to find these long, complicated ways around it. Well, functions allow you to define your own commands and expand the abilities of the programming language. Again, in the other unit, we said that there is no way that a programming language can possibly anticipate everything that you could ever want to do in a programming language. But with a base set of commands, you can write your own commands, which is great. It becomes very easy to reuse the code. Once you add this new command, it's very simple to keep using it, as opposed to constantly every time you have to use that instruction to redefine it. It does become easier to read and write. If I can break down these commands into smaller functions, could we possibly shorten the code to make it a little easier to use? Could we use names of commands to make it easier to understand? Right? Maybe when we were trying to draw the square, every time, maybe you didn't write the program, but I handed it to you and said, can you tell me what this does? Every time you saw turn left, turn left, turn left, you say, what is he doing? But if I could just call that turn right, and now I put that in the middle of the command, it's like, oh, that's a lot easier. Turn right, right? You remove the need to repeat large chunks of code. It kind of just makes the coding and the programming itself more efficient, and it breaks the program down into logical chunks. What are the major building blocks that put together this code, and could we make functions out of the major building blocks, right? Kind of going along the lines of making it easier to read and write, it gives a way to add concise, human-readable names to complex selections of code. Yes, the computer has to understand the code, and ultimately the computer is the one doing the work, but we have to be able to allow a human to be able to look at, read, and understand the function. So the more readable names you can give, the more descriptive names you can give to the parts of your programs, the better. So this idea of being able to do all the things that are listed here about functions is all wrapped up in a concept and a vocabulary word, big fancy word in programming called abstraction. Abstraction. Abstraction really means to simplify the representation of something more complex. Right? We're going to talk about what it could be a fairly complex set of directions in terms of some more simpler language that focuses less. I'll skip to here for a second. It focuses less on the major ways to solve the problem, or the major parts of solving the problem, rather than the nitty-gritty details. If we can avoid having to talk about very specific details, could it make it easier to understand the larger problem and be able to talk about it in larger terms? So this is a concept called abstraction, where we're going to simplify the representation of something that's a lot more complex. Okay, and here's an example of kind of how what exactly we're trying to do with abstraction. I don't know about you, I love breakfast. Breakfast is my favorite meal of the day. If I can have breakfast for dinner, I often do. So if I asked for breakfast, maybe our program's point here is to make pancakes. First of all, make pancakes could be a very this is a much larger idea. This is the big concept here about I'm going to make pancakes, right? But if I was going to maybe program this, I would have to break this down into smaller parts, because there's a lot of things that have to happen between no breakfast and pancakes on the plate, right? So this idea is called top-down design, where we're going to take this large concept, make pancakes, and I want to break it down into smaller subtasks, right? Smaller things that have to happen in order to make the large picture work. So what if we made this? Well, these are the steps to making pancakes. We need to organize our kitchen. We're going to make the pancakes and serve them. Okay, so these are the three major steps, or these are three of the major steps involved in making pancakes. Well, you have to look at those major steps you've come up with now and say, is there a way to get even more specific? Is there anything that should be broken down within each one of these? And the answer is sure. So if we broke those three major tasks down, do you get something like this, right? So what does organize the kitchen mean? Well, organize the kitchen means let's clean the counter, let's get out all the equipment we need, let's get all the food that we need, and let's put on an apron, right? So maybe these are the directions on how to organize the kitchen. Okay. Maybe here are the directions on how to make the pancakes. So we have to sift salt and flour in the bowl, break the eggs into the bowl, whisk, add water and milk, add butter, whisk, and cook. These are the different parts that go into make pancakes. Okay, so we've just now taken organized kitchen and broke it down into its smallest parts. But if I look at all of this, this is pretty straightforward. When we get to cook, though, I think cook could even be broken down even more. And text is getting smaller, right? So in the cook method, or the cook function, we have, these are the steps on how to cook pancakes. Get the pan to temperature, pour the batter in, spread the batter, use the spatula, check the bottom, when brown, flip, etc. So if we looked at this, here are the different ways that, or the different parts about making pancakes. This is called top-down design, where we're going to divide a system into simpler subsystems. We're going to divide a large task into simpler subtasks. So I tried to make them bold and blue here, but imagine that these are all functions. So we could call the make pancake function, great, but the make pancake function is really just calls to other smaller functions. Maybe we'll call the organized kitchen function, which has a set of directions inside of it. Then we'll call the make pancakes function, which has a set of specific directions inside of it. Inside make pancakes, we're going to call the cook function, which has smaller directions inside of it. And then we'll call the serve function, which has directions inside of it. So in some ways, and unfortunately my picture here is covering the box, this strategy is an informal way of repeatedly dividing a system into smaller subsystems. As these pieces of the original problem get smaller and smaller, eventually you'll arrive at pieces that you can program solutions to in a straightforward manner. We're trying to break down a larger task into its smallest subtasks, right? And can we use those collection of small subtasks to be able to now take care of the whole problem, right? In some ways, is it easier to think about a problem little parts at a time that build on each other, rather than having to think about how do I put together the whole thing? The only other way that I can describe it is when we started talking about this particular unit, we talked about Legos. I was talking a little bit about Legos. If you've ever done Legos before, they don't hand you a picture and a bag full of pieces and say, go. What they do is very systematically take you through building this little piece, right? Let me put these pieces together. Great. Now that you have this piece put together, add these pieces to it. And slowly by slowly, in these smaller, compact subtasks, you eventually start to build something crazy. Sometimes it is a lot harder for us to think about big problems, big problems, and try to solve them all at once. It is a lot easier to break down that large task into its smallest possible units and let me try to solve little problem here, little problem here, little problem here. Can I then use those little problems to solve the next problem? Right? So this is this idea of top-down design. Can I take a larger problem and divide it into smaller, simpler subtasks? And by the time you write simpler, smaller code to fit those little subtasks, now you can start to use the subtasks to solve the larger problems. Okay? So this is more of a way of thinking about programming. It's a way of looking at a problem and trying to figure out what's the best solution. And rather than tackling it all at once, why don't we try to break it down into smaller, simpler subtasks, which are easier to write and understand, which then can be used to solve the whole problem.